The title of this session by Rudy Neufeld is Coding Introduction with a Math Focus Through Robotics and Logo, a virtual hands-on activity with follow-up opportunities. Coding through robotics models teaching with understanding. Coding has become a vital skill for the 21st century. It gives learners direct participation in and responsibility for their own learning. The computer language Logo models a learning environment which encourages one to teach rather than simply to tell. Logo is an intuitive, simple, yet powerful visual coding language designed especially for young learners. Dr. Seymour Papert of MIT developed this powerful coding language, which uses code to direct a robot on the floor or on the computer screen. I met Dr. Papert at MIT. The meeting determined my future direction in education. Logo is a model for learning. One learns from mistakes. In these examples, we are learning by teaching a robot. In the first example, from 1990, working in a classroom. And in 2020, we are working with the Bluebot robot. Logo is referred to as the language of learning. The robot speaks mathematics, and through the use of challenges, participants will discover how mathematics can build structure and design. In this virtual session, we will give access to coding and robotics to capture the interest of participants in interacting with mathematical concepts using video and exploring further hands-on activities. We will give participants free access to a robot on your computer screen, as well as guided activities for you to follow along, if you wish, during this session, as well as after. For free, complete functionality to the Terrapin Logo learning environment on your own computer, enter the address shown here in your browser. The following will appear. Click on the second graphic. Then enter the classroom name that you will be given for this session. Two panels will appear. The graphics panel has a robot at the center, and the listener panel is where we write code to command the robot. The following examples will demonstrate the Logo learning environment. I will start the first example by using some simple commands. First, in the listener panel, I'll enter home, clear screen, set width 3. This sets the width of the path that the turtle takes so you can see clearly. I'll use a slow turtle, and I'll set the pen color to 4, which corresponds to red. When I hit enter, all of these commands are executed at once, but you'll only see the final command, set pen color, because the turtle hasn't moved yet. So let's write another set of commands. We'll start at the home position, clear screen, and now let's move forward 67 and turn right 90 degrees and back 67. I enter that and now the turtle has moved, so we've got a code that gives us action. Now let's clear the screen, and I want to chunk the next set of commands, which is a process where I can break a line into parts and see what's happening one step at a time, which is a good tool for problem solving. So let's go forward 67 and hit enter. Then let's turn right 90 and enter. And let's go back 67. Let's clear the screen. And let's clear the text as well for clarity. Now I'd like to repeat 4 times, square brackets, go forward 60, turn right 90, and pressing enter, we get a square, which is what we would expect. Let's add a bit more to this. So we'll repeat 4 times, square brackets, and let's repeat again and do a forward 60, right 90, and then at the end of the second repeat, we'll add a turn right 90. I would discuss this with my partner or group and come up with a prediction of what we think will happen here. Hitting enter, let's see what we get. And there are many more commands we could use, but this gives you an idea of the learning. I'm going to clear the screen, and let's go home, and let's clear the text as well. Building on the previous line, let's add a forward 60 and see what happens. And if this wasn't what we wanted, we can learn from our mistake by adapting our commands. In Logo, we build progress on progress. We build knowledge on knowledge. So suppose I want to teach a lesson. Let's call it box. I type 2 box and enter that, and we get this editor screen. The 2 tells me a lesson is coming, and I'm going to teach it to create a box. It's repeat 4 times, go forward 60, and right 90. Now if I click the Run button, we get the message, box defined. So it's like you go to school and learn a lesson based on certain concepts, and then the next day you build on what you already know. So I built a lesson box based on commands that I had learned previously, and now box becomes a new command, a new concept that I know. As a teacher, I would test that concept, so let's enter box and see if we get what we thought we would get. Really, we're seeing whether we have taught it correctly. Are we going to get what we expect? So we hit enter and we get this shape. Now let's try repeat 4, and we can be more efficient now. Let's make a box and then turn right 90 and enter that. So we have taught a new lesson based on present knowledge, as you do in school. We have taught the turtle to make a box. Then we tested that lesson to see if you, the teacher, have taught it correctly. Use the new lesson to build knowledge on knowledge. We could now make another lesson that draws multiple boxes in new ways, and build upon that as well. This is a simple example, but it gives you an idea of what is possible here. And you can see that it showed. Coding through robotics models teaching with understanding.